Hi everyone. So we are discussing the solutions of Job-A-Thon. I hope you had attempted all the three problems. We are going to discuss each problem one by one. Starting with the first problem, product modulo check. The problem states you are given an array of integers and an integer y, and your task is to determine whether there exist three distinct indices I, j and k. Right, distinct indices such that they are in strictly increasing order. Second thing is the product of values at these indices. The last digit of the product must be equal to y. If this is the case, then you are going to return true, else you will return false. Now let me walk you through a test case. The first test case says 2, 5, 10 and 3, and we are given as y0. So if I select I as 2, like I as 0, j as 1 and k as 2, the product of 2 into 5 is 10 and 10 into 10 is 100. So the last digit of 100 comes out to be 0 only, which is equal to y. That's why we are returning true. This is the problem statement. Now I am going to explain the logic behind it. How are you going to solve it? Cool. So this is our whiteboard. So let's start. You are given an array which contains some numbers, right? This is some indexing 0, 1, 2, 3, 4, and you will select some I, some j and some k, and you are going to access these values into ARR of j into ARR of k, right? And check whether, let's say, this product comes out to be k. So the last digit of this k must be equal to y in order to return true. So this is again a simplified explanation of the problem statement. Now tell me one thing, or think of one thing, ki if I am doing 2 into 5, right, and then I am multiplying 5 with 10, so the product comes out to be 10. Now if I take the last digit, which is 0 only, and if I multiply it with 10, the product will come out to be 0 only. The point I am trying to make here is, whenever you are multiplying any of the three digits, let's say we have another example. Let's say 17 into 2 into, let's say, 3. So 17 into 2 is 34. I am taking the last digit and I am multiplying this with 3. Now I am getting 2 as the last digit, because 4 into 3 is 12. So I am taking the last digit only, right? Now let me check what is the multiplication of 34 into 3, which is nothing but 3 4s are 12, 3 3s are 9. It is coming out to be 102. What matters here is the last digit only, right? So the last digit comes out to be 2. In this case, the last digit also comes out to be true. So this states that we have to find the last digit only. None of the multiplication of larger digits matter. Cool. Now let us proceed slowly to the solution. So as we discussed, the last digit matters. So there is a possibility that my array contains a lot of big numbers. Now let's say I have got three numbers a, b and c, whose product is going to be matching with the last digit, right? Now can you think of some possibilities here? The possibilities is ki whether all these a, b or c could be distinct. The second possibility is whether any of the two numbers out of a, b or c might be equal. So there is a possibility ki a is equals to b, or b can be equal to c, or c can be equal to a, right? And the third possibility is कि if all the selected numbers are equal to each other. So these are the three possibilities. Now how are we going to evaluate this? So what am I trying to do is, if I try out all the possible combinations of A, B and C. Now if you think carefully, let's say I have an array. In array I have a number. Now the possibility of this number is the digits will lie from 0 to 9 only, right? Every number can be formed from these 9 digits. So let's say कि if I want to try out all the possibilities, what I will do is I will run a for loop. A for loop which is trying A from 0 to 9. Now I will run another for loop which will try B from A to 9, and finally I will try all the possibilities which will try C from 0 to 9 only, or C to 9 we can say, right? So these are all the possibilities of A, B and C, if you have got it. Now let us try कि we need to check whether all these possibilities, if they are present inside the array, we need to keep track of it, right? कि whether A is possible or not, like A exists in the array or not, B exists in the array or not, C exists in the array or not. Now how can we check this? For this I am trying of maintaining a frequency array. A frequency array will be containing what? The frequency of every element in the array, right? So I'll check for the frequency of every element in the array. How can I do this? So I will maintain a frequency array. Just a second. Yes. So I will maintain a frequency array. Now how I am going to store numbers in this frequency array is the most important thing, right? So let's say I have a number, let's say 19. I have a number, let's say 9999. If you think carefully, or what I have told you in the start, the last digit only matters. So if somehow I can extract the last digit and store the frequency of these digits, then it will be a best option. So if I do modulo 10, I will get 9, right? If I do modulo 10 of this, I will also get 9. So are you getting my point? While iterating on my original array, I am going to store the frequencies of 0 to 9 only, and I will initialize it as 0. Initially the frequency of every digit from 0 to 9 is 0. Now I will, when iterating over it, I will store it like modulo, and if I found it, I will increase the value of it by 1. So that's pretty much about the problem. What we had used a frequency array to store the occurrences of the last digit of every element, right? So in this problem, like in this, 9 is appearing 2 times. How are we doing this? By simply modulating it by 10, right? Now second thing is, we are trying out all the possible combinations of A, B and C. For this I am running 3 for loops, one inside another. Now what are the total possibilities? 0 to 9, 0 to 9, 0 to 9 can at max go up to 720, but if you try to think from your mind, I am running the loop from A to B, then B to C. Basically I am starting and every loop inside from the upper loop element. So the possible combinations comes out to be 220 only. So there will be a order of 220 operations, if you think carefully, right? This is combinatorics. The last thing, I have 3 possibilities. The first possibility, if all the indices or all the numbers A, B and C are distinct, right? Let's say 1, 2, 3. So 3 2s are 6 and 6 1s are 6 is 6 only. The second possibility is any two of the numbers from ABC are equal and one is distinct, right? And the last possibility is all of them are equal, right? A equal to B equal to C. So let's say I have to focus on the last digit must be 9 only, and I have three numbers 19, 999 and let's say 3999. What I will do, I will just extract the last digit 9 into 9 into 9, then I will multiply them. This will give me what? 81. I will again modulate it with 10 because only the last digit matters to me. So I will do 1 into 9, which is comes out to be 9 only, right? And since 9 matches with 9, I will straight away return true. So that's pretty much about the problem. Now we are going to move to the coding part. Try to code it by yourself first, then look at the solution. Cool. Let's proceed to the solution now. So let me focus. Now, first of all, what I had created is I had created a frequency array of size 10. Why? Because I have the possibilities from 0 to 9. 10 digits are possible. I have initialized all of them with 0. Right? I hope the code is visible. Just a second. Okay, now I had initialized all of them with 0. Now, what am I trying to do? Is I am iterating on my original array and I am storing the frequency of every element, the last digit, because it is what matters to us, right? So I am modulating every digit, every number of the original array bit 10 and making it frequency increasing by 1 every time it appears. Now I am running 3 for loops and trying all the possible pairs of A, B and C. So first loop is running from A equals to 0 to 9. The second loop will run from B equals to A to 9, right? And the third loop will run from C equals to B to less than equals to 9. Now I am calculating the last digit. So last digit would be A into B. Whatever we had got, you remember 9 into 9, that is 81. I modulated it with 10 because last digit matters to me. This comes out to be 1. Then I will again multiply it with the last digit, that is the third possible digit, which is 9. So 1 into 9, which is something. Let's say whatever the product comes, it is also greater than 10. The last digit matters to us, so I will again modulate it with 10. Now I am checking if the last digit is equal to y or not. If it is not equal, then I'll straight away check for other possible pairs, right? So if it is equal, now I am checking for 3 conditions. What are the 3 conditions? The first condition is if all pairs are same. Let's say the pair comes out to be 9, 9 and 9. So this pair 9, 9 and 9 is giving me the correct answer, which is equal to 81 or whatever in the 9 in the end, right? Now I have to check whether my frequency array have at least 3 nines or not. If my frequency array have at least 3 nines, this means there are 3 possible numbers I can select from my original array and can make the product equal to the answer, right? So this is the first check. Second check I am doing is I am checking for the 3 possibilities, whether A equal to B or B equal to C or C equal to A, right? Now I am checking whether the frequency of A is greater than or equals to 2. At least it should be greater than equals to 2 and frequency of C must be greater than equals to 1. Similar is happening for the other 2 cases. Now the last possibility is if all are distinct. If frequency of A is greater than equals to 1, means I must have 3 distinct numbers. So the frequency of all of the distinct numbers in my frequency array must be greater than or equals to 1. If any of the condition is true, I will straight away return true, because first of all I have got a possible pair. Second, the pair is possible in my original array. Right? Now, after running all the possible combinations, let's say we had never returned true, then in the end I will return false. And this is how our solution code gets executed. Let me try to run it. Compile and run. Okay, so yes, our code runs. Your output is true, expected output is true, compilation is okay. Let me try to submit it. Nice. So we had problem solved successfully. The time taken is 0.2 and we have got all the test cases passed. So this is the solution of this problem. I hope you had understood the problem. In the next section, we are going to discuss the other two problems.
Hello everyone, I am Vyom Rastogi and I will be discussing the second problem of Job-A-Thon, towers and jumps. So first try to understand the problem. We are given three arrays here: height array, jump array and query array. What is height array? Height array defines the heights of building. So let's say if the size of height array is 4, 4 buildings will be given and their heights will be given. Okay, let's say for this example 2435, 2, 4, 3 and 5. So these 4 buildings are given with height 2, 4, 3 and 5. Now what the problem statement is saying, that a person can make jumps on each of these building. First we have to understand, on each of these building a person will be standing. Okay, all of the person are different and on each building one person is standing. Let's say one person is standing here. Okay, now this person can make jumps. How? This person can make jump to the next immediate tower which have strictly height greater than its current height. So let's say if it's standing on the building 0, let's give them index 0, 1, 2 and 3. If this is the current building where this guy is standing, he can make jumps to the right side but only to the to that building which have a strictly greater height than it, and only the next immediate tower. What this means is, check for 2. So if a person is standing at 2, he can make a jump to 4. If a person is standing at this building with height 4, he can make jump to this building 5. Why not 3? First 3 is lesser than 4 and it, okay, so 3 is lesser than 4, that's it. Now let's see for 3. From 3 the person can make jump to 5. Okay, and from 5 he can't make any jump, no jump. 0 jumps he can theoretically make. Okay, 0 jumps he can make. Now a person standing at 2 can't directly do a jump to 5. It is in the right direction, it is strictly greater, but the condition is he have to make a jump to the immediate tower only, so only to the next greater element. Here one jump is defined as going to next greater element. Okay. Now second array. Second array is given to us as the limit of jumps one person can make. In one jump, what is happening? A person is going to the next greater element. Yes, and he can make a maximum, some maximum jumps he can make according to the jumps array. Okay. Now you can see in each jump a person is making, the height of the building is increasing. So if a person take a jump from 2 to 4, the height has increased. From 4 to 5, he can make another jump and he will be able to reach the tower with height 5. So with each jump, the maximum height a person can reach is increasing. Okay. Now what is asked to us in this question? We are given a query array, and in query array, for each query, let's say if in a query 3 is given, then we have to tell the number of people which can reach a maximum height greater than or equals to 3. Okay, this we have to tell. Now if we have to tell the maximum number of people that can reach a greater height, that can reach a height greater than or equals to 3, or query that can reach a height of greater than or equal to query, what we have to do, we want to maximize the height each person can reach. It's good for us greedily, it will be better for us that we try to maximize the maximum number of jumps one person can take. Why? For each person, the maximum height one person can reach is increasing. Yes. So for me, I will try to maximize the number of jumps one person can take. Okay. Now if you will see, the person standing at index 0 can first take a jump to index 1, and then from here he can take a jump to index 3. Yes. So theoretically he can take only 2 jumps. This is theoretical limit, like according to the question limits he can only make 2 jumps. Yes. Now jump condition is also given to us. Jump condition is also given to us. For this example, the maximum heights this problem is allowing me is 1 jump only. So if you see here, the maximum height for the person standing at 0th building will be 4 only, because he can make only 1 jump at maximum. According to the heights tower, he can make 2 jumps, but according to the jump tower, he can make only 1 jump. Yes. So I will be taking the lower limit 1 jump, that is 1 jump this person can make. Now let's try to calculate the maximum height which a person can reach. If we see here, for 1 jump, what I have to find? Next greater element. Yes. For each jump I have to find next greater element. If I have to find in 1 jump what will be the maximum height, I will find next greater element. Yes. If a person can take maximum of 4 jumps, then I will try to find 4th next greater element. Okay. If a person can take maximum of 4 jumps, then I will try to find the 4th next greater element. How I can do this? 2 ways are there. One way is I can try brute force. That is, let's say a person was standing at 2 in some random array. Let's just imagine, for this element 2, next greater element will be 4. For this 4, next greater element can be 6, and then for this 6, next greater element can be 8. Yes, and again for this 8, 10 will be next greater element in some random array. Yes, so one jump he will be able to reach here, second jump he will be able to reach here, third jump he will be able to reach here, and fourth jump he will be able to reach here. Brute force way is you can keep calculating this next greater jumps. Like the first next greater jump, first next greater element will be this, second will be this, third will be this, and fourth will be this. Yes, but this will be very slow, because for a person maybe n jumps can be allowed, and n here can go up to like if you see 1e5. Okay, 1e5, the size of this jump size can go up to 1e5, and jump of I can be up to its limit is up to jump of size. So one person can be allowed to do 1e5 jumps. So for each person I will try to find the kth next greater element like this. It will be very slow. So what we will be doing, we will use the same concept through which we find next greater element. How we find next greater element? With the help of stack. Yes, so I will be using stack only to find kth next greater element. What this k is? K will be the limit of jumps a person can make. Yes, how we will find this? We will just see in a short time. Now through example I will tell you how to find this kth next greater element. So the example will be like this: 2, 4, 3, 5, 1 and 7. Let's try to find a kth next greater element for this. How we will be able to do this? Try to imagine a stack. What this stack will be holding? This stack will be holding next greater elements. As I have to find the next greater element, I will start going from the right direction. So first I will put 7 here. Yes, stack was empty, no element was present. So for 7 I can't there is no next greater element. No kth next greater element could be possible for 7. Yes, when this will be the case, when no kth next greater element is available, when either the stack is empty. Yes, if the stack is empty, then this means no next kth greater element exists, or the size of stack is lesser than k. Yes, now 7 I have pushed. Let's try for 1. When I push 1, I know all of the number which will be in the stack. I want to maintain these number as next greater element. So for 1, when I am pushing 1, I will see that 1 is smaller than 7. Yes, so for 1, next greater element will be this 7 only. Okay. Yes, now try for 5. When I push 5 into this array, what will happen? 1 is smaller than this 5, so I will pop 1. I will pop 1. After popping 1, I will push 5. Yes. Now see for 3. For 3, this top of the stack is already greater than 3. Okay. And for 5, 7 was already greater. If 7 would have been smaller than 5, then I had already popped this. I have not popped 7 because 7 was greater than 5. Yes. So what I can see, in this stack all the elements will be arranged in an increasing order. All of these elements are arranged in an increasing order. The top of the stack will be the lowest value, and after this, each time you start going into the depth, these numbers will start increasing. Okay, so push 3 here. For 3, if you see here, for 3, first the next greater element, the first next greater element, NGE, let's call it NGE. For 3 it will be 5, and second NG, what will be second NG? It will be 7. Yes. Now let's try for 4. When I will be pushing 4, I will first check top of the stack. Top of stack is smaller than 4, so I will pop this 3. Let's pop this. Okay, again I will check top of the stack. 5 is present, 5 is greater than 4. So what I will do, I will push the 4 into the stack. Wait. Yes. Again now if you will see, for this number element 4, first next greater element will be 5, second next greater element would be 7. Okay. Now let's try for 2. 2 again I will try to push. I will check top of the stack. 4 is greater than 2. Okay, so no popping. I will directly push the 2. Yes. Now see for 2. What will be the first next greater element? This element which was present at the top of the stack will be first next greater element. 5 will be second next greater element. Third next greater element would be 7. No fourth next greater element exists. Okay. So if in the question it was given that the person standing at this building, whatever this building would be, if a person is standing at this building and he can make at most, the limit is given like he can make 5 jumps. Yes, if it is given in the question that this person can make 5 jumps, he will not able to make those 5 jumps. Why? Because theoretically only 3 next greater elements exist for this element, so he can only make 3 jumps only. Okay, so now I will have 3 cases here. If let's say jump I is if my jump of I, that is the maximum number of jumps which I can make, is greater than my stack, size of stack. One case will be this: if jump of I is greater than size of stack, then I will not be able to make these much jumps. There will be a limit. Yes. So what is the maximum height then this person can reach? If jump I would be greater than size of stack, then this element present at the back, the last element present in the stack, that is the maximum height this person 2 will be able to make. Okay, one case will be this. Second case will be like this: if jump of I is equals to 0 or stack itself is empty. Stack is empty. Then this means no jump will be possible. Yes, no jump will be possible. If no jumps are possible, then the height, the starting height where the person would be standing would be the maximum height. That would be the only maximum height this person can reach if no jumps are allowed. Okay. Now let's discuss the third case. What will be the third case? If my jump of I is smaller than my stack size. If it is smaller than stack of size, let's say maximum jumps I could make was 2. If it was 2, what is the maximum height now we can reach? In one jump I can reach this maximum height. In second jump I will be able to reach this height, 5. So 5 will be the maximum height. But here's a problem. If I use a stack, in stack I can only access the top of the element. Yes, I cannot randomly access these element. है ना? I will not be able to access randomly these elements. So if I would be saying jump I of is less than stack of size, then just directly access the jump I element. So like if it is what 2, just check the second element from top of the stack. That will not be possible, because I would have to first pop off element, then again for the next building for which I will be calculating, I will again then have to push. That we cannot do. So what we will be using, either you can try to implement stack using arrays. Okay, what you can do there, you can create a top variable that will define you the size of the stack, or you can use DAC also. In DAC, let's erase all of this. So I will be using DAC. So how DAC we can use? If let's say this is my DAC, in DAC I can insert and delete from both ends, and we can access any element present in this DAC using indexes. So what I can do this decay of 0. What this will represent? It will represent this element, 0th. The first index will represent this element, second element index will represent this element. Okay, so this is how we can use a DAC, and we can randomly access any element present between there in the present between in the DAC. Okay, now 3 conditions I have given you. If jump of I is greater than the stack of size, what my stack is representing? My stack is representing the maximum number of jumps theoretically a person can make, like based on the height array. Based on the height array, what is the maximum number of jumps a person can make? That is represented by my stack size. I will be using DAC, so you can also say size of your DAC. Okay, if jump of I is greater than my DAC size, then what is the maximum height this person can reach? This element, whatever the element present here, let's say X, Y, Z, whatever will be the element present at place here, that will be the maximum height one person can reach. So maximum height the person which can reach will be equals to dq of 0. Okay, second condition will be like this: if either of stack is empty, or like the maximum number of jumps a person is allowed is 0. Okay, then what will be the maximum number of height a person can reach? The height of the current building where he is starting. From the point a person is starting, then that will be the maximum height. Okay, now for third, let's try to see for third case. What will be the third case? If jump of I is lesser than dq size. Yes, this will be the third case. Now what will happen in this? Let's say the maximum number of jumps a person can make is 1 only. So this number I will have to return. Yes, next greater element. If a person can make only first jump, then I will have to return next greater element only. If let's say that person can do maximum of 2 jumps, then second next greater element I will have to return. Yes. So how I will access these elements? What I can do simply is dq dot size minus jump of I. Yes, because if jump of I value is 1, then I will have to access n minus 1, dq size minus 1. This element will be referenced by dq size minus 1. If I keep increasing jump of I will have to decrease this number. Yes, so for jump of I to dq size minus 2 number I will have to access. Simple. These 3 conditions you have to do. Now by doing this, for each building you will be able to calculate the maximum height you can reach. Okay, for all of these building you can store this maximum height h, let's call, in an array. Let's call in array h. You will be storing all of this maximum height. Yes. Now once you have calculated the maximum height for each building using this concept, what you can do, you can sort this array and use binary search after this. So after sorting, let's say your array will be like this: 1, 2, 5, 6, 8. Let's say this is your maximum height array. Okay, now for each query, if I have to tell the total number of pupil which can reach let's say height of greater than or equal to 5. If I have, for a query, I have to tell the total number of pupil which can reach a height greater than or equal to 5. What I will do, I will just find lower bound for this. Lower bound for query I will find. Yes, I will found a pointer here. Yes, and what I can simply do, I can subtract it from n. So the total number of 3 people will be able to reach maximum height of 5. Okay, let me show you the implementation. So now n, this is the heights of my size. I am defining 2 variables here. dq, dak, I am defining one variable, one vector I am defining for my height. Here I will be storing my maximum height. Okay, I will start traversing from the right side, and I will use the same concept which I have explained. Using dak we will be doing that. If dak is not empty, or the height, the current element which I am accessing have a greater height than the top of that stack, top of the stack, if it have greater height than top of the stack, I will pop the element. Okay, now for this element at I will have 3 condition. Yes, this I have told. First condition, if either stack is empty or jump I equals to 0, then height I will be the maximum height which I can reach, the current height. This is the current height of the building, that is the maximum which I can reach. Or if the size of stack is lesser than jump of I, so what is the maximum number of jumps which I can make? I will be able to make total dq dot size, like whatever will be the size of the stack, I will be able to make those much jumps only. So dq 0 I will be pushing. Okay, else I will push this dq dot size minus jump of I. Yes, in the end I will again push my heights of I in the DAC. Okay, for calculation of kth next greater element. Yes, once this calculation of DAC is done, I will sort my array. Okay, so now I will start iterating each of my query, and for each of that query I will implement lower bound. Yes, for each query what will be the answer? N minus lower bound. Simple. I will push this answer into my returning vector, and I will return this returning vector. Okay.
So yeah, hi everyone, and I'm Ramneet, and so we'll be discussing of the last problem of the Job-A-Thon. So yeah, let's just start with reading the problem. It says you are given a string and a list of string which is dict, and you have to find the maximum number of non-overlapping substrings in S such that in S that exactly match any word in the dict. And there is also a note given which is each word from the dict can be used multiple times if it appears multiple times in S, but overlapping substrings are not allowed. So okay, let's understand the question by an example. Let's say if we have string as, let's say, yeah. So let's say if we have string as EF, yes, we have EF GZ X N and Y, and also we have given a array dictionary, so which contains, let's say, EF and EF GZ and ZX. Also it has NY, and the problem says is that since it says that we have to find the substring of each element in the dictionary. So let's say if we have a first element as EY, we can see that EF occurs at here, and this, like we can say that EF occurs at 0 to 1 index, 0 to 1, like we have these indices, and there is no other place where EF occurs, so we can just simply have 0 to 1, and we have another element which is EF GZ. So if we check, EF GZ lies from 0 to 3, and we also have ZX appears at 3 to 4 index, and NY appears at 5 to 6 index. So and if we see the question says that we have to actually maximize the number of the substring in the S, and let's say we have this, so we have to make the string by the substring such that no substring overlaps, and we can have EF is our answer, and we can have ZX, and we can have NY. Like we can construct a string by these substrings, and you can see that it is from 0 to 1, and ZX is from 3 to 4, and NY is from 5 to 6, which means none of the strings are overlapping. And yeah, so we just have to maximize the number of the substrings that are present in dictionary such that none of the substring overlaps in the string. And if we carefully observe, if let's say if I consider, let's say if I try to make a string by EF, and EF GZ, I can't really make it, because the thing is it is from 0 to 1 and this is from 0 to 3. We can see that these are overlapping. So in question it is strictly said that you cannot the overlapping substrings are not allowed, and here it is overlapping. So the thing is, I'll just erase this, and this pair actually is not valid. So first this pair is valid. We have EF and ZX and NY. This is valid, and the count is 3. And is there any other pair valid? Yeah, we can say that EF GZ and can we, yeah, can we make this as pair EFGZ and ZX? You know, this Z and this Z is overlapping. It is from 0 to 3 and ZX is from 3 to 4. It is overlapping. We cannot have this in our answer. So can I say that I can have NY instead of ZX? It would be EFGZ and NY. So it is from 0 to 3 and it is from 5 to 6. So no, none of the strings are overlapping. So we can get 2 as an answer from here. And there is one more valid pair, which is okay. I guess these are the only valid pairs. And what we have to return is the maximum count of substrings we can have in our answer. So this is valid, even this is valid, but because this is like we want to return the maximum number of non-overlapping substrings, so we'll be returning this as our answer. We just have to return the count. So you know, from the question you can observe one thing, that okay, first the question says that we have to count the substrings. So initial thought is that we have to find all substrings. We have to find the all substrings and all substrings in S of each and every element, present in dictionary, array. So you know, like if we try for EF, we can see that only this is the, like at 0 index we can find EF, and for FGZX we can have, okay, we can only find it as F. We have to maximize the number of non-overlapping substrings. And you know, if let's say we somehow find all the substrings in S of each and every element in dictionary, let's say we have this EF, we can have 0 to 1, and for FGZX we can have 1 to it is I guess 4 1 to 5 indexes. On for ZX we can have, I guess, okay, let's write it here. We have EF, G, Z, X and Y. For EF only substring is 0 to 1. For F, G, ZX we have 1 to 4. We have 1 to 4. And for let's say ZX we have 3 to 4. And for NY we have 5 to 6. And you know, here let's suppose we also have EF, G, Z. Let's suppose our dictionary also contains this element. Initially it has F, G, Z, X. Let's say if we also have EF, G, Z, it would be 0 to 3. Okay, let's say we somehow calculated, like we somehow find all the occurrence or the range of that particular substring in S. And now what we have to do is, now let's say we have 0 to 1, we have 0 to 3, and we have 1 to, yes, so we have 1 to 3, and sorry, it's 1 to 4, and then we have 3 to 4, 5 to 6. We have 1 to 4, 3 to 4 and 5 to 6. You know, these are all the occurrence of the element present in the dictionary in S. And you know, and now what we have to do is we have to return the maximum number of non-overlapping substrings. So just think one thing. If let's suppose we have okay, will it be better we choose 0 1 or 0 3? Like what would be better, like which one of the string will give me the maximum answer. In order to maximize the number of strings, number of substrings, I will minimize the length of the substring, minimize the length of substring. Let's understand it with one example. Let's say we have A, and we have a dictionary which has A and A. So for this A, we can have that, this could be a possible answer, like all the substrings we can have 0 to 1, we can have 1 to 2 as well, we can have 2 to 3. And for this A, we can have 0 and like 0 to 0, and we can have 1 to 1, we can have 2 to 2, and we can have 3 to 3. So from this thing we can, okay, we have this AA, we have this A, we have this number of A's, and we have this number of A's. And from this, just try to think, should we ever pick this A in our answer? Because let's suppose I can choose this one A and this one A, which will give me the complete string, and they are non-overlapping. And if I choose only A, single element, I will get 4 A's. Here I get 2 A's, and here I am getting 4 A's. So it's better I choose single A's, or can I say I have to choose the substring of the length, like of the minimum length, rather than taking the substring of the maximum length. And so yeah, this is actually the main crux. The thing is, let's get back to this example only. EF, GZ, X, N, Y, and if we have EF and EF, GZ in our dictionary, and let's say we have NY, we have ZX and NY. Yeah, these are the 4 elements in our dictionary. For EF we have 0 to 1, EF, GZ we have 0 to 3, and ZX we have 3 to 4, and for NY we have 5 to 6. Let's try to make a combination. Let's say if I choose this element, if I choose 0 to 3, now with this my substring from the range 0 to 3 are, like I can't choose any more substring, like I can't have this substring, or let's say if I have substring something like 0 to 2 and 0 to 3, if I choose 0 to 3, so I won't be able to take 0 to 2 because it's overlapping now. And similarly, let's say if I choose 0 to 3, I can't have 3 to 4 in my answer because 3 and 3 is overlapping. So it's better I always take the minimum ending index. So okay, let's say if I have these pairs, so and one pair is I can make 0 3 and then 5 6, or I can have 0 1 and then 3 4 and then 5 6. So it's, you can see that here it is giving us 2 elements, like 2 substrings, and here we are getting 3 substrings. So it's always better to take the substring which has a lesser length and which has a lesser ending index. So yeah, like from this we get to know 2 things. First we have to find all the substrings. Let's say I use any algo and I find all the substrings in the S. So yeah, and the second thing is I want to pick the substring from all the substrings in such a way that the substrings are non-overlapping. Let's say this is some array, like, so we have to pick something like which is non-overlapping. I can't really have this and this in my answer. So So the second thing is, I want to pick substring from starting which has lesser ending index. So because here if we would have considered, let's say we have fgzx, and fgzx has the element from 1 to 4, and because we can see that, okay, this is the example we were discussing, x and y, and let's say we have ef. So is it better to pick this or to, let's say, fgzx, or to pick this? Because let's say if we try to pick this, so then in question we also have zx, so we won't be able to pick this element. But if we would have picked this element, we can now take this element in our answer. So it's always better to pick the substring which has a lesser ending index. And so yeah, so the first thing is how to find the substrings, and for this we can just simply run 2 for loops, or it's just simply brute force. I'm hoping that you know how to find the substrings, and we can just simply run 2 for loops, one inside another, that's the nested for loops, and then we can just simply store the starting index and the ending index of that particular substring. Let's say if we have all the starting index and ending index pairs, and then what we can do is, if let's say we have all the starting index, ending index, then we can sort each and every string by the ending index. So let's say this is something like, let's say this was some pairs and we have sorted, so it will always look like something this, and let's suppose we have 2 and 6. So let's say these are the pairs and we have already sorted in by the ending index. And now the thing is, we'll first check this element. We can see that we just have to greedily pick the elements which has a lesser index. We know that at start it would be lesser, we can just simply pick it. And now if we want to pick this, we just have to check that if the starting index of this element is greater than the ending index of this element after sorting, then only we can pick it. But the thing is, here we have 0 to 1 and here we have 0 to 2. You can see that it is non-overlapping, so we can't pick this. Similarly, we can't pick this. It's 0 to 1 and 1 to 2, it's still overlapping, and we can't pick this as well, and now we get 2 and 6. It is 0 to 1 and 2 and 6. We can pick this and this as well. But okay, and the thing is, let's suppose we wouldn't have picked this element, we would have directly picked this 1 to 5 in our answer. Let's say 1 to 5, then we would have never able to take this element 2 to 6. So it's always better we pick the lesser, we pick the element which has a lesser ending index. So we got 0 to 1 and 2 to 6, which gives us the answer 2. So yeah, we just have to find the substrings and then we just have to have all the pairs and then just simply sort by ending index and just simply we can greedily pick the, we can just simply traverse to each and every element. We can have our, let's see how we can actually pick. Let's say we have some pairs 0 to 1 and 0 to 3 and 2 to 4 and 2 to 6 and let's say 5 to 6. So let's initialize our last with -1 initially. We have to check that if this current element starting index is greater than the last, we can see that it is -1 and 0, so we can actually pick this element. So we get 0 to 1 in our answer. Then we have to update last by the last index of this array. We can update -1 to 1. Then we again have to check for this element. If starting index of this element is greater than the last, which is not, we'll move forward. We just have to check again. Here we have 2. 2 is greater than 1. Then we can have this in our answer 2 to 4. And we can update last as 4. And then we'll check if 2 is greater than 4, which is not, we'll skip it. Now we can see 5 is greater than 4 and we can just simply have 5, 6 in our answer. So we get 3 pairs, which is 3 distinct substrings in our answer, and the answer would be 3 at last. So yeah, and so this is it for the solution. And there is one thing, like to find the substrings, one way is to do a brute force, which is O of n square solution. Let's have O of n square solution, and if we see the constraints, it is 1e5, so even the string is 1e5 and the element is 1e5, so it would be 1e5 times 1e5 times 300. So we can't really, so this won't work. So there is one more, like we have to use any string matching algorithms, and we can use any algorithm. For now we'll be using KMP, and yeah, so you can find the KMP algorithm in the description as well. I won't be explaining it right now. And we can, so the thing is, KMP help us to find all the substring in a S in just O of n plus the length of the substring, let's say m. And what we have to do is we have to traverse the complete dictionary, and we just simply have to calculate the substring for each and every element. That would cost us 300 times O of n plus m, which we can actually do so. And now this is for finding the substrings. And the one thing is, we can't actually store all the pairs, because what happens is, let's say we have A in our answer, we have A and A. Let's say this is the string, and we have A as dictionary and A as dictionary. For this A, we'll be actually having this 0 and 1 and 2, and for this A as well as we'll be having, like it is for range. I'll just, let's say if we check for this A, we get a range from 0 to 0, we get a range from 1 to 1, we get a range from 2 to 2. And for this A, we'll get range from 0 to 1 and 0, not 0, it would be 1 to 2, and it would be 0 to 1 and 1 to 2. Yeah, so we'll be having only 2 substrings. We can see that this and this are overlapping. So one thing I said is we'll always pick the element which has a lesser index. So it's always better we actually store this 0 rather than storing this element. And even we have 1 to 1 and 1 to 2. We only want this in our answer, we don't want this. So to do this, what we can have is, we can have any map. We can just simply have, for the particular starting index, I will store the, like initially let's say we get 0 to 0, like let's say the dictionary is something like AA, Okay, let's say, yeah, we first got 0 to 0, we can have 0 to 0, and then we got 1 to 1, we can have 1 to 1, and then 2 to 2, and then again we get 0 to 1, which is starting index at 0, ending at 1. So I just said we'll try to pick the element which has a lesser index, so I won't be updating it, I will keep this 0 as it is. So the thing is, let's say we have this string and it is A and A, and so for this we'll first get 0 to 1, we then get 0 to, sorry, not 0, we get 1 to 2. Yeah, so let's say we find all the substring for this element which is 0 to 1 and 1 to 2, then we came to this. So for this we have 0 to 0, so it's always better we pick the substring with a lesser index. We can actually make 1 as 0, and for even 1 it would be 1 to 1, we can make it as 1, and then we get 2 to 2, we can just simply have 2 to 2. And now since we got all the pairs in the map which has a lesser ending index, we can just simply create an array which will have all the pairs 0 to 0 and 1 to 1 and 2 to 2. Then we can just simply sort it by the ending index, which is, for this case, it is already sorted, and then we can just simply traverse from each and every index. We can have a last variable and just compare the starting index with the last, and if it is greater than the last, we can just simply have an answer variable. We can increment our answer by answer plus 1, and yeah, then we can just simply keep going it. So yeah, that is it for the problem, and let's check the code. This is the code. What I am doing is I am calculating the substring by using the KMP algorithm. For KMP we first calculate the LPS array for the pattern. So what I am doing is I am traversing the dictionary, and for each and every substring I am calculating the LPS array and computing the KMP. And what I am doing is, instead of storing it in a map, I am just directly storing it in the result array, and which is for every starting index of that particular substring. I am storing the ending index, the substring starting index, which will contain the minimum ending index. For each and every starting index we will be having the minimum ending index. So, and then it is the simple KMP algorithm, and then what we are doing is we are actually creating a pair of each starting index and the ending index, and then we are sorting the complete pair, and then this is the algorithm. Here we have answer initialized with 0, last at -1. We are just simply checking if the pair starting index is greater than last, we'll increment our answer and we'll update our last with x dot second, and we can just simply return our answer. So yeah, that is it for the problem. Thank you.